Right, let's look at buffer solutions. A buffer is a solution that only changes slightly when an acid or a base added to it, or a solution that resists changes in pH when an acid or base is added to it. So let's look at the different types of buffer. We can have an acidic buffer, which is made by weak acid and its conjugate base. And we can also have a basic buffer, which consists of a weak base and its conjugate acid. Typical example, or most common example of acidic buffer is ethanoic acid and its conjugate base, sodium ethanol. And another common example of alkali buffers is ammonium and its conjugate base, conjugate acid, ammonium chloride. Okay, so let's look at how buffer solutions work to resist changes in pH. Now, we make buffer solutions when we want to have a system where pH does not change drastically if an acid or base comes in. What this means is that the buffer solution should be able to mop up any H plus that come in, or OH that comes in order to prevent a drop or an increase in the pH. So let's look at our acidic buffer, which is made of ethanoic acid and sodium ethanoate. If we add acid into the system, the acid will bring additional H plus that is mopped up by the weak base component of the solution, which is the sodium ethanoate. So the sodium ethanoate will react with any incoming acid to form ethanoic acid. Now, in doing so, there will be additional buildup of H plus in the system, which will cause the pH to drop. Okay. On the other hand, if we add a base, say we add sodium hydroxide, the hydroxide ion that's coming in will be mopped up by the weak acid component of the buffer system, which case is the ethanoic acid, to react with the OH that's coming to form ethanoic ion and water. In this case, there won't be additional buildup of OH ions in the system, causing the pH to rise. And so, if we do that, we having the pH maintained at a constant range. We won't have an increase in pH. So that's how buffer solutions work to maintain constant pH.